Hi, I'm Dr. Roger Seheult. Over the past 4 years, we've produced top quality videos explaining concepts in medicine clearly. These courses are the product of years of experience and preparation that includes only these things. Number one, you either need to know it for the test, or number two, you need to know it to become a great medical professional.
Hi, this is John Cullen. Welcome to another episode of Heroes of the Pandemic. Allow me to introduce you guys to Dr. Roger Seheult. And Dr. Roger, could you say hello to everybody, if you would?
Hello, everyone.
There we go.
Thanks, John.
You bet. It's an absolute honor and a pleasure to have you here.
Before I became a physician, I worked for a national test prep company, and I taught the MCAT and the USMLE. Now, I'm board certified in internal medicine, pulmonary diseases, critical care medicine, and sleep medicine. I still have a busy clinical practice and actually treat the diseases that I talk about. It is this experience that separates MedCram.com from all the others. I know what kind of questions show up on the test because I write the test questions for medical students. I know what's important, and now you will too. Join us at MedCram.com.
Ohio has 17,000 people dead, but Ethiopia has 2,300 dead. Okay? Connecticut has 7,600 dead, but Ethiopia has 116 million people. You see, Connecticut doesn't, right? Connecticut doesn't have 116 million people. Connecticut has 7,600 dead. Ethiopia has a fraction of that. This is where it falls apart, doctor. You need a map. You need a map guy. You need a map guy who knows data. And you're looking at him. You're looking at one of the most populated countries on Earth, and Connecticut has more dead. Egypt has over 100 million people. Ohio has more dead. I'm looking at the most populated countries on Earth. I'm looking at Pakistan. I'm looking at Nigeria. I'm looking at Bangladesh. Right? I go to Pakistan. Ohio has more people dead than Pakistan. Pakistan is the 5th most populated country on the planet. 220 million people live in Pakistan, and Ohio has more people dead.
So they're getting if I'm not mistaken, they're getting the data from those political entities, right? So the aggregated data sources on this Johns Hopkins site, I mean, they're the consortium, but they're not the ones that are actually on the ground getting the data, right?
Well, the decisions that are being made are based on this data. I mean, this is the source. This is it. This is from the WHO, from the CDC. You know, there is no more authoritative source than what we're looking at.
Right, but the data for Pakistan is coming from the government of Pakistan. And the data from Lithuania is coming from the government of Lithuania. And the data from Kazakhstan are coming from the government of Kazakhstan, right?
Right, sure.
Yeah.
Right.
Yeah.
But these are real countries, right? These are real countries, and the WHO has a response. Like, this is the WHO's job, right? The WHO's job is to do this, right? So their job is to keep track of this stuff, right? So Bangladesh has 8,400 people dead, according to the WHO, right? And we pay them money to do this, right? That's the whole idea. 165 million people, fewer dead than Ohio. Okay, 165 million people, way fewer dead than California. California, 50-something thousand. Mongolia has 2. But Mongolia has a huge border with China. Now, there's no curiosity whatsoever as to how Mongolia, with this massive border with China, has only 2 people dead. Nobody wants to know about that. Nobody's curious, okay? What about Laos? What about the fact that Laos shares a border with China and that all of the road commerce that goes to Thailand from China goes through Laos? Because Thailand and China do not share a border. You have to drive through Laos. There's nobody dead in Laos, doctor. No one. No one is dead in Laos. Are they lying? Is Laos lying? Why would Laos lie? What about Cambodia? Is Cambodia lying too?
Why would any country lie?
Right. So there's nobody dead in Cambodia. There's nobody dead in Laos. Mongolia has 2. And I'm in the region, meaning I'm looking at countries near China, bordering China. Mongolia shares a massive border with China. 2 people are dead. Laos, nobody's dead. Cambodia, right. No one is dead. Vietnam has more people than any country in Western Europe. Vietnam has 100 million people.
And yet we hear stories about, 2.1 million cell phone numbers are out of service permanently in China.
Nonsense.
And we hear these stories about, satellite images of crematoriums in China that are off the charts.
Nonsense.
So, I don't know which one you put stock in, but if,
I put it in the WHO. I put my stock in the WHO and Johns Hopkins, right? I'm looking at the Johns Hopkins stuff, right? This is the official stuff, right? I'm not a conspiracy theorist. I'm looking at the data. I'm going straight to the WHO. I'm asking the WHO, what you got? And they're telling me you got 35 dead in Vietnam. I'm not a conspiracy guy. I don't want to get killed for exposing what I'm exposing. I'm showing you their data. Did I hack into the system? No, I'm pointing at the map. Taiwan hates China, right? They hate China. They're almost at war. There's 9 people dead in Taiwan with 24.5 million on the island. 24.5 million people live there.
Well, they actually did a pretty good job early on of shutting down the island.
Nine. You're not going to explain it away, doctor. You're not going to explain away 9.
No,
9.
I'm just saying that I'm no shill for Taiwan, but they did do a pretty good job of shutting things down.
Yeah, and nobody called them. How come? Why didn't Cuomo call? Why didn't Newsom call? The phone, he doesn't have a phone with a number 7? He can't call, it doesn't call Taiwan?
I don't know. Is that what you need to call Taiwan?
I imagine there's got to be a 7 in there. I mean, what's the excuse for not picking up the phone and calling Taiwan, calling Laos, calling Vietnam?
I got another phone though. I didn't have much money, so I had to get an irregular phone. It had no 5 on it. Phone had no number 5. I was walking down the street and I bumped into a good friend of mine. He said, "How come you never call me anymore?" I said, "I can't call everyone I want. My phone has no 5 on it." He said, "That's really weird." He said, "How long have you had it?" I said, "I don't know. My calendar has no 7s.
Yeah, they came up with testing very early on, but the CDC did not want to adopt their testing, and they wanted to have their own, and so we were weeks behind.
CDC labs reportedly caused weeks of delays in rolling out coronavirus test kits to states that
State officials say the CDC is reformulating portions of test kits that were flawed. In today's news conference, state epidemiologist Sarah Park says the CDC plans to send new kits to all public health labs in the next week. Governor David Ige added he spoke to the CDC and says because of Hawaii's location, it would take the state at least a week to get any test results back. That's why Hawaii needs its own test kits.
I do think there's been a mischaracterization about, quote, the flub. We developed the test, as I've mentioned to you before, literally within probably 7 to 10 days from the sequence. That test was developed at CDC to put eyes on this outbreak for our health departments. That test was never flawed. It works fine today as it did then. When we did try to expand that test to give it to each of the local health departments, there was a manufacturing problem in one of the reagents that had to be corrected that took about 5 weeks. And then we corrected that for the public health labs. But the defect, the real defect from my point of view in the whole response was that the private sector took a long time to get involved to provide testing for the medical community at large.
Wait a minute, you think the defect is in the private sector? I understand the difficulty of moving things just from state labs to private sector. That wasn't done fast enough. But there was basically just sloppy lab work, according to the New York Times, in the test kits themselves. And as you said, that delayed things for 5 weeks. 5 weeks is, that's a critical 5 weeks.
So there's a lot of mistakes that happen.
Well, according to Nigeria, they had well over 100,000 cases. It's not like they're not counting.
They probably took advantage of the WHO's testing that we didn't.
Mm-hmm. Well, again, it's not like they're not counting, but they've only got 2,000 dead in Nigeria with over 200 million people. So they're laughing at Connecticut.
Yeah, there are certainly we can talk about potential reasons why, in all seriousness, the United States is more at risk for deaths than many other countries in the rest of the world.
No, because it's nonsense. It's nonsense, right? If there's 35 people dead in Vietnam with 100 million population, what you're witnessing is something different from what you think you're witnessing. I'm going to show you what it is. I'm going to show you exactly what it is because I figured out what it is. If you look at deaths at COVID by age group, we know it's the older people who are dying, right? I categorize it into 3 groups, 1 to 44, 45 to 64, 65 and older. It's quite apparent what we're dealing with here. It's a 65 and older problem for the most part. 45 to 65, if you've got, if you've got diabetes, if you've got other things that put you at risk, absolutely, it's an issue. But 44 and younger, it doesn't seem to be that big an issue. We talked about the number one comorbidity. We know that 6% of the deaths don't have one. That's great. It used to be that there was 2.6 on average. Now there's, what does it say? Now it's 3.8 additional conditions on average for comorbidities. And they changed the system. This lower left-hand corner is what it used to look like. This is what it looks like now because I've been showing people how to use it. So using the numbers, what we figured out is how many people have something. So for example, if there's 200 students in the lecture hall and 20 of them do not have brown eyes, how many do? It's a pretty easy formula, right? 180 of them do. You either do or you don't have brown eyes, right? Mm-hmm. There's not a third choice. You either have brown eyes or you do not have brown eyes, right? Same thing with influenza. And so it turns out there's a group that had it and there's a group that didn't. And it turns out more of the kids are dying with both than not. So this is comorbidity, meaning if you test with COVID and influenza, that's not a good combo. Nobody knows this, doctor. This is a deadly combination. More kids are dying with both than not. Okay? Now, you can understand why, right? If somebody comes in and they got both COVID and H1N1, that's a double whammy. That's like getting shot with a shotgun and a rifle. I mean, that's not good, right? It's a double disaster. The only reason I know this, doctor, is because I'm looking at the mortality data. I'm looking at the death certificates. Now, don't you find this a little bit bizarre that over the last 3 influenza seasons, we had 195, 144, 180 something kids die, and this season there's 1? Wouldn't you call that an outlier? I'd call that an outlier.
I got to be honest with you. It's this doesn't ring true for what I'm actually seeing in the front.
Right.
I think there may be some. I think there may be some reporting issues in terms of those 2 columns that we talked about at the beginning, where if you look at it, one is with pneumonia, one's without pneumonia, and that may be causing the difference.
No, they're all with pneumonia. Everything is with pneumonia. So the PNI, PNI, right? PNI is standard, right? It's always with pneumonia. And the COVID, the same thing. They're not, and it's only 6% that wouldn't have the pneumonia, right? It's only 6% that wouldn't have it. So Laura and everybody else is saying, well, where's the flu? Where's the flu? Well, the CDC has this thing called influenza burden that they report. And they said that the influenza burden for the season was 22,000 deaths. But it turns out that influenza burden is not how many people died. Influenza burden is very complicated.
Mm-hmm.
It's a very complicated formula that uses ratios of hospitalizations and visits and all this other stuff. And quite frankly, I'm not really interested in it because it's so complicated. I want to know how many people died. And that's in their little formula at the top of the pyramid, died. How many people died? I don't want to know about hospitalized and symptomatic visits and hospital utilizations divided by beds. I don't need all. I'm not in your business. I'm not a hospital administrator. So I don't. Influenza burden is like a hospital administrator's thing. I just want to know how many people died. That's it. I don't need to know about symptomatic illnesses and hospitalizations and utilizations. That's for people in your world. Us people just want to know how many people died last year. And it's not 22,000. 22,000 is all this stuff. This is 22,000. You got to calculate the apex of the hypotenuse over here. And if you don't do all that, you're not going to get to that. That's a problem, doctor. Because America thinks that 22,000 people died. And the PNI mortality system shows us that 274,000 people died. That's a big difference, doctor. In the 2019-2020 influenza season, the PNI mortality system shows 274,000 deaths for the season. It is unprecedented. It has never happened before. And I've got all 7 years here.
In 2017-18, we had the worst seasonal flu that we've had in memory, about 80,000 deaths and almost 1 million hospitalizations.
As COVID-19 arrived, we were already logging 4,000 PNI deaths a week in the United States. From from January 1st, which is week 1. It starts in October, week 40. Once we got to week 1, we were at 4,000 a week going into COVID's arrival. Then COVID shows up. Okay, so now as COVID arrives, what happened? Did the influenza just completely disappear? Well, let's see what happened. The blue is the influenza. Can you see the blue? And then the green shows up. The green are the COVID deaths. Now, this is mortality. These are death certificates, not tests, right? This is death certificates. So as the COVID shows up and we start logging deaths, we get 3,000 deaths in week 13. But influenza went up also. These are 2 different systems. I've got a PNI mortality system that's been there for years, been there since 2013. And we've got a brand new COVID system where I'm getting the green stuff from, okay? The next week, did influenza just disappear that next week, or what happened in that next week? What happened? Let's see. Oh no, influenza went up and COVID went up, but influenza was a little bit higher than COVID, just a smidge, just a tiny bit higher. What happened in the next week? Oh, well, this is interesting. This means we can't be double counting because now COVID is higher than influenza by more than the amount that influenza went up. And what happens in the next week? Influenza went down and COVID went up. Now we know for sure we're not double counting and that we have two discrete systems. This is data analysis. Again, I'm not a doctor. I don't need a stethoscope for this. This isn't stethoscope stuff. This is my stuff. You've got two different systems. You've got two different infections, and they're both killing people at the same time, and one of them is subsiding in week 16 as the other is getting worse. I don't need to be a doctor to tell you this, doctor. And in the next week, influenza deaths go down again, as does coronavirus. But then if we play the whole thing out, this is what happens. Blue is influenza. Green is coronavirus. There are certain weeks where influenza was higher and certain weeks, many weeks, where coronavirus was higher. But they both exist. And what you're dealing with is a co-infection scenario that only the coroners are aware of. And I'm guessing you don't hang out with a lot of coroners. You don't have a lot of coroner friends.
Well, let me tell you, first of all, no autopsies get done. Hardly any autopsies get done. This is something that we used to do a long time ago, but we don't. It's just they don't have the ability to do that. But getting more to the point is when patients come in with a viral pneumonia, there is a test that we administer in our hospital. Actually, I work at two different hospitals in Southern California. Right. And it's called, this is a proprietary name, but it's very similar across the board. It's called the BioFire. Basically, what you do is you take a nasal swab and you put it through the machine, and the machine basically at once tests for about 18 to 20 different viruses. There's 4 different coronaviruses that it checks for, the ones that we previously had that were not SARS-CoV-2. It checks for SARS-CoV-2. Mm-hmm. It checks for influenza, H1N1, H1N5, H3N2, all of them, mm-hmm. and the rhinoviruses, the adenoviruses. So literally with one test, boom, patient comes back. You can look and see what they've got, and I can tell you, for the last year, I have seen probably over 100 different coronavirus patients. And I cannot tell you that I remember one patient that had a co-infection with any form of influenza.
Right.
And it's not because we weren't checking for it, because we were checking for it. We just never saw it.
Okay. I've heard from other doctors that they stopped checking and they stopped testing for it back in April, and that they weren't surprised at all by this. And said, yeah, we didn't, we weren't even testing people for it.
We couldn't stop testing for it because that was how we tested.
Mm-hmm. And how long has that kit been on the market? That fire?
That BioFire kit's been there for years. In fact, what they did was they added the SARS-CoV-2 panel to that number to the entire panel.
Gotcha.
And so it would be run as a battery.
FilmArray is user-friendly multiplex PCR. This innovative system simplifies molecular testing through a completely automated protocol, beginning with integrated sample preparation and ending with automated analysis of results. Starting a FilmArray run is easy. All of the reagents required to test a sample are preloaded and freeze-dried into the reagent storage compartments of the FilmArray pouch. To begin a FilmArray run, the pouch is first placed into the loading block. Then, hydration solution is injected into the pouch through the blue inlet port on the right. The vacuum in the FilmArray pouch automatically draws the correct volume, eliminating the need for precise measuring and pipetting. Next, sample is added to the FilmArray sample buffer. This solution is then mixed and then injected into the FilmArray pouch through the red inlet port located on the left side of the pouch. Again, the vacuum in the pouch automatically draws the required volume. The FilmArray instrument is now ready to set up. The FilmArray pouch is loaded into the FilmArray instrument, and a barcode reader is used to enter the pouch ID. The sample ID can also be scanned with the barcode reader or entered manually. Last, the user ID and password are entered and then the run is started. You are free to walk away since all remaining steps are completely automated. The film array displays the remaining time. Now let's take a look at what happens inside the pouch. First, the sample is moved into the lysis chamber where the film array physically lyses any cells and viruses through a process called bead beating. Ceramic beads are agitated at high speed to break open cells and viruses and release the nucleic acids. These nucleic acids are then bound by magnetic beads, which are then moved from the lysis chamber to the purification chamber. Here, a wash buffer removes any remaining cellular and viral debris. The film array activates a magnet outside the pouch, which holds the magnetic beads in place while the debris is washed away. Next, an elution buffer releases the purified nucleic acids from the magnetic beads. The magnetic beads are again magnetically secured while the nucleic acids are moved to the first stage PCR chamber. A reverse transcription step is performed to convert any target RNA into DNA. This is followed by a high-order multiplex PCR involving dozens of primer pairs. During this first stage PCR, many reactions simultaneously occur in this single large volume reaction. The products from the first stage PCR are then diluted to limit any remaining first stage PCR primers. Next, the diluted first stage PCR products are combined with a fresh master mix and then aliquoted to each well in the array. Each well of this array is pre-spotted with one pair of second stage PCR primers. These second stage PCR primers are designed to amplify sequences contained within the products from the first stage PCR. This eliminates non-specific products associated with traditional multiplex PCR. Because the second stage primers specifically amplify only target DNA. A fluorescent double-stranded DNA binding dye is used to monitor each reaction. The second stage primers in each well are designed to detect one specific target. Organisms are identified based on which wells in the array are positive. The film array performs a melt to confirm the presence or absence of specific temperature signatures of the second stage PCR products. The film array software processes the data and makes a positive or negative call for each organism. These results are provided in one easy-to-read report. From integrated sample preparation to automated result analysis, the film array is user-friendly multiplex PCR. Each well of this array is pre-spotted with one pair of second stage PCR primers. These second stage PCR primers are designed to amplify sequences contained within the products from the first stage PCR. This eliminates non-specific products associated with traditional multiplex PCR. Because the second stage primers specifically amplify only target DNA.
live it our way. All these words I don't just say, and nothing else matters.
Are you familiar
That's what
with?
it was.
All right. Are you familiar with the work of Jeffrey Taubenberger from 2005? And they went to Breivik Mission, Alaska, to get the Spanish flu variant. You know about that?
Yes.
All right.
In your lungs, where you need them clear for oxygen, for gas exchange, and pneumonia is really, really deadly. It always has been, and it still is, and that's what killed people in 1918. The other clue is that it was an H1N1 virus. And so how do we know that? We know that because people like Jeff Taubenberger and his team have actually gone back to tissue samples from 1918. So here we have wax-embedded autopsy tissue samples taken from a victim of the Spanish flu. And Jeff Taubenberger and his team take slices of that material and they amplify up that genome that we saw before, so we know exactly genetically what this thing looked like. In fact, the one complete genome that we have from 1918 comes from here. So this is a place called Breivik Mission, which is a little village in Alaska. And in 1918, the Spanish flu pretty much wiped out the whole village. And a lot of people ended up in mass graves. And this guy here, Johan Hultin, he's a virologist who for years had been saying, you know, we might be able to get virus out of those graves. If they were buried in permafrost, you might have good preservation of material. He tried in the 50s, at a time before genomics and amplifying gene sequences. What he needed to do then was actually get a live virus. Couldn't do it. Not possible. Everything's kind of dead and fragmented. So he went back in the 90s on a solitary trip. I thought this was funny. So he carried just one tool, a pair of garden clippers borrowed from his wife without permission. And let me just go back. There they are. Okay. So, from this mass grave, via Mrs. Hultin's garden clippers, to the big screen. That's not just a flu genome, that is the Spanish flu genome from that victim, from that mass grave in Alaska. Those A's, C's, G's, and T's are the virus that killed that person and so many others in 1918. And I can remember.
Because the second stage primers specifically amplify only target DNA.
Well, what you're looking at now are the PNI deaths since long before COVID. Long before COVID, there was PNI.
Yeah, no, I remember we had a bad, the year before COVID, we had a very bad H1N1 year. I remember patients coming in literally dying in the emergency room of cardiac arrests.
All right, so hang on. Hang on. That was 1 year ago now. That was January 2020.
Yep. That's right. It was actually, November, December.
Yes.
But
okay,
yeah.
So I've documented that. I put a video out that's on my channel that talks about the deadliest virus on Earth, which is H1N1. So we look at that work that was done by Jeffrey Taubenberger. They sequenced the Spanish flu H1N1, which is not a seasonal flu. That's a wicked one, right?
That was a shift, yeah.
All right. Imagine if that accidentally got out of a lab. Yeah. Imagine in the summer of 2019, if there was an accidental escape in Australia in August of 2019, because you know that in December, January, February, the United States was experiencing the worst influenza outbreak it had ever seen. I'm showing it to you in the screen right now. The dead people. We had over 4,000 a week dying.
Mm-hmm. I remember it.
And then your hypothesis is it disappeared upon the arrival of coronavirus. Of course not. How would it just poof?
Well, there's a lot of reasons why it could. I mean, we know that influenza is spread by the same way most airborne and droplet respiratory viruses are spread. So
we go back here though. I want to look at the death certificates. According to the coroners, 4,000 people were dying every week going into coronavirus.
Well, those death certificates are not filled out by coroners. They're filled out by physicians.
Okay.
I fill out those death certificates.
Okay. So up till week 11, you guys were saying everybody's dying of the flu. It's P&I, 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 P&I. 4,000 a week. In week.
Yeah, and of course, we didn't even know what SARS-CoV-2 was.
Okay, so there's a possibility. So this is where we go with this. Were these COVID deaths? But shouldn't somebody be looking at this and saying, wait a second, we have 4,000 people dying a week?
They were looking at it, and if we had those biofires and it said, H1N1 influenza, then that's a no-brainer. That's influenza.
I get it.
Easy.
I get it. I'm not trusting your test kits. As soon as your test kits were testing for coronavirus, I don't trust them. At that point forward, I no longer trust them for influenza because of the work of Taubenberger.
Tonight, we began a special series about the threat from influenza. Every year, the seasonal flu emerges and kills tens of thousands of Americans and hundreds of thousands globally. But there's an even graver concern. Public health officials fear the emergence of a new, previously unknown flu virus that could be far more lethal and become a pandemic by spreading across the world. As William Brangham reports, it's happened before.
The flu was attacking her lungs and filling them with fluid. She was then medevaced to University of Pittsburgh Medical Center, where she was eventually put under the care of Dr. Holt Murray.
The lungs become very boggy, they fill with water, and you're not able to move oxygen from the outside world into your bloodstream.
You can't breathe.
You can't breathe, yeah.
It kept getting worse. Her lungs were failing. She was put on a ventilator, but even that couldn't get enough oxygen into her.
It was a nurse who slipped up and made a comment about me dying. And I was just like, what? Oh yeah, you died like twice. You were on a machine to keep you alive. And I'm like,
that machine, called an ECMO, took out her dark, depleted blood, pumped it full of oxygen, and fed it back into her body.
And it runs through the pump in the oxygenator and comes out cherry red.
That is a very intensive intervention to try to save someone's life.
It's as intensive as it gets. We're taking 5 liters of blood a minute, taking it out of the body and returning it.
It went way, 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 way up.
Days like that are what keep Dr. Anthony Fauci up at night.
In 2017-18, we had the worst seasonal flu that we've had in memory, about 80,000 deaths and almost 1 million hospitalizations.
Dr. Jeremy Brown directs the Office of Emergency Care Research at the National Institutes of Health, and he wrote the book Influenza, the 100-year hunt to cure the deadliest disease in history.
We are definitely seeing a higher number of flu cases this year than versus last year.
The States may be reaching a peak, and so far it looks like a more severe season than others in recent memory. John Yang gets an update on why and what you need to know.
This flu season started earlier than in the past, and the Centers for Disease Control says it's the most widespread outbreak it has ever seen.
Way, 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 way up.
Days like that are what keep Dr. Anthony Fauci up at night.
In 2017-18, we had the worst seasonal flu that we've had in memory, about 80,000 deaths and almost 1 million hospitalizations. You do that every year for 20, 30, 40 years.
That's a huge toll.
At the end of that time, that's a huge toll.
Myself this way. Life is ours, we live it our way.
about 80,000 deaths.
In today's morning rounds, this flu season is on track to be one of the worst in recent history. In terms of the number of people infected, flu is now widespread in almost every single state, and nearly 10 million people have become ill so far. 4,800 of those people have died.
Take a look. You see all that red? I mean, how could you not? That should be a red flag about just how bad this year's flu season has gotten. The CDC says influenza is widespread in all but 2 states and Washington, D.C. It's that map, that rampant spreading virus we should be worried about. Let's bring the focus back to where health officials here say it should be. The flu.
There's basically no treatment for this except support. Intubation, for instance, if the lungs fail. The coronavirus is a big deal.
But Raim says there's something bigger that should have us all worried.
Influenza is way more infectious and way harder to stop.
In the first 2 weeks of 2020, the flu killed about 5,000 people in the U.S., mostly through associated pneumonia. The Centers for Disease Control and Prevention estimates that so far this season, there have been nearly 15 million flu illnesses, 140,000 people sent to the hospital, and 8,200 deaths in the U.S.
More and more attention. Some local emergency room doctors are warning.
While the CDC carefully monitors the coronavirus outbreak in the U.S., some emergency room doctors warn the common flu this season is so far much more deadly and getting worse.
And I've seen an uptick in the number of flu cases over the last several weeks.
The numbers may surprise you. From October 1st, 2019 through January 25th, 2020, the Centers for Disease Control estimates nationwide 19 million to 26 million people had flu illnesses, and 10,000 to 25,000 died from the flu.
We are definitely seeing a higher number of flu cases this year than versus last year.
close, no matter how far. Couldn't be much more from dark.
Flu season in the United States may be reaching a peak, and so far it looks like a more severe season than others in recent memory. John Yang gets an update on why and what you need to know.
This flu season started earlier than in the past, and the Centers for Disease Control says it's the most widespread outbreak it has ever seen.
I started my career in advertising. It was sort of on the heels of one of the most iconic campaigns in the ad game, which was the Think Different campaign that Apple put together. It talked about there's certain people that bucked convention, that did things different from the way that things were done. And because of their approach and the way that they thought differently, they were able to make some profound and fundamental changes. You can look at various behavior of some notable people in history, Albert Einstein, for example, even some historical figures like Mozart, recent figures like Amelia Earhart, even Steve Jobs. And they displayed some very classic behavior of people on the spectrum. I was reading a report that was published in the Journal of Autism and Development Disorders. It talks about how people on the spectrum are programmed to think differently. And they did a series of tests. They asked a number of people, I think there was a sampling of about 350 people, and they asked them to look at common things like paper clips and identify alternative uses for these common items. A neurotypical response to that question would have been things like a pin or a fish hook or a piece of jewelry. People on the spectrum gave answers like a ballast for a paper airplane or chips for gambling. And they found that their responses were less than 5% of the common responses of the whole sample size. So they were actually, quantitatively different. So people on the spectrum, the right side of the brain, the one that answers, as they say, for the creativity, for the common experiences, the more sort of social behavior, it's impaired. It's one of the reasons that they are the way that they are. There isn't really a social common behavior that they have. There aren't the same references that they share with people. So people on the spectrum, their left side, the more logic side, not only is it not impaired, because it's what they use more often, in some cases it tends to be more developed. And the theory that came out of this piece was people on the spectrum, they approach problem solving differently because that's the way that they're wired. I think many people remember the Think Different campaign. It talked about there's certain people that did things different from the way that things were done. And there was a 1-minute film basically celebrating that. They kind of went through and selected some iconic figures who, just through their sheer willpower or because they thought differently, changed humanity for the better. And it just so happens that many of these people that changed the face of humanity, that thought differently, were on the spectrum. As I said, including Steve Jobs, who is suspected to have had Asperger's. If you include the 18 people highlighted there, 13 of the 18 people were either diagnosed as being on the spectrum or suspected to have been on the spectrum, which is pretty amazing. And there was never a brief, at least I never read about a brief, that we're looking for people on the spectrum. They were looking for people that thought differently.